Friends, last class we discussed about the chemical equations. Chemical equations, I hope you understood. So in that, how to balance the chemical equations. So what is the importance of chemical equation? So we discussed. So in today class, we will discuss about types of a chemical reactions. Types of a chemical reactions. So in these types of chemical reactions, we have nearly 5 types of chemical reactions are there. How many types? 5 types of chemical reactions. How many types of chemical reactions, ma? 5 types of chemical reactions. So what are these 5 types of chemical reactions? The very first one is combination reactions. Combination reactions. Combination reactions. And second one is decomposition reaction. Second one is decomposition reactions. Decomposition reactions. Then third one is displacement reactions. Third one is displacement reactions. Next, fourth one is double displacement reactions. Fourth one is double displacement reactions. Double displacement reactions. And last one, fifth type, that is oxidation and reduction reactions. Oxidation and reduction reactions. So in these oxidation and reduction reactions, so both are takes place in same reaction means, so those are called redox reactions also we will discuss. Redox reactions. So that time, so fifth and sixth one we will discuss on separate class, but don't worry about that. So now we had a very first one we have to start today, combination reactions. Combination reactions. It's okay, everyone should listen properly. So if you have any doubts, you can do comment. Okay, so combination reactions. So for these combination reactions, we have a lot of definitions are there. Lot of definitions. So the more definitions are there, more than one. So very first one, let you see. So here combination reactions means generally we can say two or more substances. Two or more substances combines to form a single product. So carefully you can observe what we can form single product. So this type of reactions are called combination reactions. These reactions what we called combination reactions. Combination reactions. So according to this, so A and B are A and B. So A plus B gives rise to C. A plus B gives rise to C. Means here what are these reactants? Reactants. This one product. What is this one? Product. Means A and B, two reactants combines to form a C product. Means what you were given the definition, two or more substances combines to form a single product. So those reactions are called combination reactions. So okay. So previously we discussed starting one activity. Magnesium burns in presence of oxygen to form magnesium oxide. So already we know that equation also. So what the magnesium burns in the presence of oxygen to form magnesium oxide. Here magnesium and oxygen, two different elements to form a single product, that is magnesium oxide. What is this? Magnesium oxide. It's okay. So what are the another definitions? What are the another definitions of these combination reactions? So another definitions, what are the another definitions of combination reactions? See, very simple. So whatever I give an example, no? What is? Two or more elements can combine. Two or more elements. Two or more elements combines to form a new compound. So the above equation, you can see magnesium is an element, oxygen is an element to form magnesium oxide. This is the product. It's okay. Next, at the same time, an element and a compound. What? Another definition. An element and a compound element and a compound combines to form a new compound. Combines to form a new compound. So what is the example for this type of this definition? What is saying? An element and a compound. Element and a compound both are combining here. So let you see the example. What we call this example? What is the next example? You can see once. Okay. Next example we will discuss. For this, we can write the example. So what are element and compound? So here 2CO gives a plus O2. So carbon monoxide is burns in presence of oxygen to form carbon dioxide. Here CO is the compound and oxygen is a element. So CO2 is a new substance, that is the new product. So okay ma, new product. At the same time, one more definition. What is the one more definition? Here, a compound. So one compound, one or two more compounds. Here both compounds we can take. Both compounds we can take. Two or more compounds. Two or more compounds. Two or more compounds combines to form a new product. So for this, we can write the example. For this, we can write the example. So what is the example here? Ammonia. So what is the formula of ammonia? NH3. Ammonia reacts with hydrochloric acid to produce ammonium chloride. So here ammonia is a compound and HCl is a compound. Finally, we can get ammonium chloride also compound. These are the three definitions of different ways to explain the combination reactions. We can see other examples. Means whatever we discuss now, element and compound, compound and compound. So in all the cases, what happens? One and only compound will form. Two or more reactants combines to form single product. In all the cases we observed, single product only formed here. So we discuss some other examples of combination reactions. Okay. Other examples of combination reactions. Other examples of combination reactions. So, example 1. One by one I will discuss. Example 1. So, in this example 1, hydrogen gases combines with oxygen gas to forms water. Hydrogen gas combines with oxygen gas to form water. So physical states, this is also gas. Here oxygen also gas and water is a liquid. So here hydrogen and oxygen, two elements, and water is a one single compound. These are two elements, these are product. The product is single compound. It's okay. I hope you understood. So next, example 2. What is the next one? Example 2. So in this example 2, we will discuss very useful example. So coal burns in presence of oxygen. What will form? We can get the carbon dioxide. So carbon can react with oxygen, burns in presence of oxygen. It can produce carbon dioxide. Here, this carbon is a element, oxygen is a element, but CO2 is a compound. So carbon is solid. This is gas. This is also gas. So along with this, what happens? We know. So next, example 3. Example 3. So here example 3, hydrogen and chlorine gases. Combines to form a hydrogen chloride. See, what is that? Hydrogen gas and chlorine gas combines to form a hydrogen chloride. So equation is balanced. Hydrogen, what is the physical state of hydrogen? Gas. What is the physical state of chlorine? Gas. HCl gas. But someone having doubt, sir, actually HCl means that is hydrochloric acid, no sir, but why you are saying hydrogen chloride? Here I am giving one clarity. So what is that clarity? Wait, I will explain. So what is that clarity means? Here HCl in gaseous form we can call as a hydrogen chloride. We can call as a hydrogen chloride. Hydrogen chloride. At the same time, when hydrogen chloride gas is dissolved in water, hydrogen chloride gas is dissolved in water, it can called as a hydrochloric acid. We can explain with one activity in discussing the second chapter, acid, bases and salts. So you can remember when we called hydrogen chloride, when we called hydrochloric acid. So in gaseous form we can call hydrogen chloride, or the liquid form. So we can't say liquid form, that is aqueous. Why? Because this HCl gas is dissolved in water. That's why we can call it as a hydrochloric acid. Hydrochloric acid. Hydrochloric acid. I hope you clarified your doubt. So, okay. Next, example 4. Example 4. So, what is the example 4? Example 4. So, in the example 4, sodium metal can react with chlorine gas. Sodium metal can react with chlorine gas to produce sodium chloride. So produce what ma? Sodium chloride, NaCl. So okay, here which is 2 here, chlorines here 2Na. Here sodium is a solid. Sodium is a solid and chlorine is a gas and NaCl is a solid. So rock salt, common salt we are using, no, that is sodium chloride means salt. So okay, clear? Here sodium and chlorine are 2 elements, but sodium chloride is a compound. Sodium chloride is a compound. So okay, next one more example. Example 5. Example 5. Example 5. What is the example 5 means? Iron powder is heated with sulfur. What is that, ma? Iron powder heated with sulfur. So we can keep the delta. Delta indicates the heating. Iron powder is heating with sulfur. It can form. What is this? Iron sulfide. What is this, ma? Iron sulfide. So this is iron is solid, sulfur also solid, this is also solid. So here iron and sulfur both are elements, not compounds. Iron and sulfur both are elements, And iron sulfide is a compound. It is in the which physical state? It is solid state. Solid state. So next example. Next example we'll discuss. Next example. So in previous which example was 5 gana? Okay. So next example 6. Example 6. So this is very important. Already they given in the activity also. So okay. Oh, here we can know some words. Later I will discuss. So example 7, calcium oxide. What is this, ma? Calcium. I am writing words. Calcium oxide. Calcium oxide combines with water. Combines with water. Combines with water to produce calcium hydroxide. Calcium hydroxide. Calcium hydroxide. So calcium oxide, this is also known as lime. This is also known as, or this is called as lime or quicklime. Lime or quicklime. Sometimes they won't ask calcium oxide. They can't say calcium oxide. So sometimes what you can say, quicklime is reacting like that. That's why you should keep knowing. So what is the calcium hydroxide? Is called as a slacked lime. What is this? Slacked lime. So sometimes dry slacked lime also we can see. So what is the calcium oxide formula? CaO. So generally we are using for whitewashing, powder. So putty we can call putty. So whitewashing. So the formula is calcium oxide CaO. It is reacting with water. It is reacting water to produce calcium hydroxide. Calcium hydroxide. Calcium hydroxide. Here, so calcium oxide is a solid and water is a liquid. And calcium hydroxide is also solid. Calcium dry slacked lime. Solid. Okay, ma? Calcium hydroxide is a solid. I hope it is clear. Okay. So here calcium oxide is a compound, water is compound. Finally, what we are getting the product, that is also compound. That is also compound. So this is when the formation, a chemical reaction takes place, this time some amount of heat also released. Heat also released. So it is also called as it is also example for another reaction. What is that? Exothermic reactions. In previous class I discussed, I hope. No? Okay. Example for exothermic reactions. Exothermic means what? In which chemical reaction heat is liberated or released. That chemical reactions are called exothermic reactions. That reactions are called exothermic reaction. So this reaction is a combination reaction. Combination reaction and exothermic reaction. Exothermic reaction. Exothermic reaction. So next, so it is very important. So very generally we can see this example in our day-to-day life. Yes. So actually what I said, this calcium oxide is used for the whitewash. Whitewashing. Okay, whitewashing. So what happened this whitewashing? Simply. So first quicklime is reacting with water to form calcium hydroxide. Here calcium hydroxide, if we are adding more water to this calcium oxide, we are getting slacked lime, liquid form. It's slacked lime in the liquid form. See, calcium oxide plus water gives rise to calcium hydroxide. So this is solid, this is liquid. So when we are adding large amount of water, it's what will call aqueous form. It will get aqueous form. So then we can wash. Then we can paint on walls. Which one we can paint on walls? This calcium hydroxide or slacked lime. So what happens at that time? So generally this calcium hydroxide is exposed to the air. Exposed to the air. At the same time water also evaporated. So actually within the day it can't be visible as white. Within the 1 day or 2 days can't visible. So directly you can see whitewash. Is it visible white? No. So after 2 or 3 days it can visible as a pure white color. So what chemical reactions are involved in this whitewashing? See, so calcium hydroxide or slacked lime painting on walls. So in atmosphere carbon dioxide is there. Yes or no? In the atmosphere carbon dioxide is there. This carbon dioxide can react with slacked lime to form calcium carbonate. Calcium carbonate. This calcium carbonate cannot dissolve in water. Calcium carbonate does not dissolve in water. It can dissolve only acids. You heard outside. This calcium carbonate is also present in eggshells, marble. Okay. So this calcium carbonate does not dissolve in water, and here one more water is evaporated. Water is evaporated. So here this is solid. It's okay. You can take aqueous. Wait a minute. Aqueous. This is gas. So this is solid. This is gas. Evaporated liquid only. Yes, you can keep it. I hope you understood. So this calcium carbonate is pure white color. When we can observe the white color? When we can observe the white color, ma? White color we can observe after 2 or 3 days. 2 or 3 days we can observe the white color on the walls. White color on the walls. So here a question is very important here. Actually maximum chances to come the question in the exams. Board exams will come to exams. So okay ma. Next. So how many example? This is the which example? 6. Next example 7 I will discuss. Example 7. Example 7. Example 7. So this 7 example. Already I hope 7 examples. 7th examples. Carbon monoxide. Discussed I think. Carbon monoxide. I think discuss. Okay. Not discuss. Carbon monoxide, not sulfur dioxide we can take. Sulfur dioxide is reacting with oxygen. Sulfur dioxide is reacting with oxygen to produce sulfur trioxide. Sulfur trioxide. This is what? Sulfur dioxide. Sulfur dioxide. This is already oxygen, we know. This is sulfur trioxide. Sulfur trioxide. Sulfur trioxide. So equation is balanced or not? Say yes or no? No. So okay. So oxygens are more, no? So I'll keep here 2. So 2 means how many oxygens came? 4 plus 6 came. So here to keep 2. So this is equation is a balanced. Which method we can use? Heat and trial method. So sulfur dioxide is what? Gas. Sulfur dioxide is a gas. Oxygen is a gas. And sulfur trioxide also gas. Sulfur trioxide also gas. So okay, these are the examples of. So in this case, one is a compound, another one is a element. Both are combining to form compound only. So these are the examples of decomposition reactions. In coming class, very detailed, I will discuss with you decomposition reactions. So okay, thank you. We'll meet next class. Thank you.